Alright, part 2 of the video on the coffee problem. I'll try to talk a little faster, I guess. We got the p-value, the range of p-values from our table. But if you want to know the exact p-value, you'll have to use your calculator. The range of p-values is enough to know that we can reject this null hypothesis. But let's look on the calculator how to do this. It's kind of like normal CDF, but it's TCDF. Remember, this is a T distribution. So we're going to go to second distribution. Number 6 is TCDF. And we need to put in a lower limit, upper limit, and a degrees of freedom. So the lower limit, if you think about the graph, we're at negative 3.49. On our t-score, we need like maybe negative 100 or negative 1,000. Either one of those is big enough. So I put in negative 1,000. Our upper limit is our t-score of negative 3.49. We're looking for the area in the lower part of that curve. So negative 3.49, our degrees of freedom is 19. We will paste this equation, and we get 0.001225. That is definitely in between these two values. But it is nice to have an exact p-value instead of a range of values. But you don't have to have it. The range of values would be enough to help us make that conclusion. Actually, this TCDF would be worth adding to our yellow booklets. So let's do that. Right on page 10, which is where we would get our range of values. Let's put it up at the top. P-value comes from second distribution, 6 TCDF. We got to put in a lower bound, upper bound, and degrees of freedom. So we can add that to your notes. Just remember, it's not going to be there for your AP test, but this is for your practice. Okay, now we need some conclusions. So what I have here are, I actually have 3 different sentences that help conclude this. The combination of all 3, makes a perfect answer. You probably don't really need all 3, but use your judgment about what is meaningful to conclude your hypothesis test. And there's some suggestions of words that you can use in there. So I have the small p-value of 0.00123 makes it unlikely that the low sample mean of 9.845 ounces resulted from sampling error alone. So we reject the null hypothesis that 10 ounces of coffee are dispensed. That is a great sentence because it's got a p-value, it's got context, it's got numbers from the problem. It's really good. You could also say the difference of 0.155 ounces, where'd that come from? That's 10 minus 9.845. The difference of 0.155 ounces is statistically significant, providing strong evidence that the mean amount of coffee dispensed is less than 10 ounces. If the machine was producing a mean of 10 ounces, the probability of a sample mean of 9.845 ounces or less due to sampling variation alone is only 0.1%. I probably like the first 2 sentences the best, but they're all good. I think the third sentence would not be able to stand alone. It's just kind of like some tacked on information. Alright, we can do a follow-up confidence interval. You don't always have to do that. A lot of times you'll be requested to do it. So on this one, we'll create a 1 sample t interval about the mean. Keep in mind that confidence intervals are always two-sided or two-tailed. So you want your confidence interval to match the significance level you used in your hypothesis test. We used a significance level of 5% for a 1 tail. So that means our confidence interval, we need to use 90%. Treating it as if there's a 5% area on the upper tail. So our formula is our our test statistic plus or minus the margin of error, which is T star, and this will be for 19 degrees of freedom, times the standard error. These can be X bars or Y bars. It really doesn't matter. X bar or Y bar, 9.845, plus or minus our T score for 19 degrees of freedom, And this t-score goes with a confidence interval. So it's not like the last one where we got the t-score from the sample. This is the t-score based on a 90% confidence interval. We did this yesterday, but let's recall how we do it. So at 19 degrees of freedom, we want the tail probability of 5%. So we're going to find 5% here. And at 19 degrees of freedom, 1.729. If you go on down that column, you'll see that that is a 90% confidence interval, or confidence level. So it automatically uses two sides on that. The tail probability is 5%. So 1.729 is our t-critical value for 90% confidence interval, times the standard error, which is the standard deviation of our sample, divided by square root of our sample size 20. So we can crank all that out on the calculator. The margin of error becomes 0.076787 and a lot more decimals. So our confidence interval is 9.845 plus or minus that. I got 9.768 to 9.922. What are we looking for in this confidence interval? The hypothesized value of 10 ounces. 10 ounces on a scale would be above this interval, so this interval does not include the hypothesized value, which further confirms that we made the right choice to reject the null hypothesis. Concluding that with the confidence interval language, I'm 90% confident that the population mean amount of coffee dispensed by the machine is between 9.768 and 9.922 ounces, confirming my decision to reject the null hypothesis. That's a good way to conclude that. So what I would be interested in right now is how can the computer do all of this for me. Let's first look at the hypothesis test for a t-distribution. So I'm going to do stat tests, and it's number 2 t-test. So this is like a 1 sample t-test. 2 samples we'll do later, but for now, just number 2 t-test. And you get this screen. You can input data, which we actually already have in list 1, or you can do stats. We ran one variable stats earlier, so this is already populated with most of the values we need. The null mean, yours probably says 0 right now, but we want to put our null hypothesized value mean of 10. There's our sample mean, there's our sample standard deviation that the calculator already put in for us. Okay, so what do we have? We have a one-sided test. We're proposing that our sample results are less than the hypothesized mean, and we're going to calculate. I'm not going to draw it. And so we get for an alternate hypothesis that the mean is less than 10. There's our t-score, negative 3.49. There's our p-value, 0.00122. And it reiterates our other statistics. There you go. Now remember that you need to know how to do all of these parts by hand and be able to show all the mechanics by hand. You can use your calculator to double check your results. How about the confidence interval part then? On the confidence interval, we'll go to second distribution again. And, not second distribution, sorry, stat tests. And we want a t-interval. So it's number 8, a t-interval. We're going to use stats again. It's already populated everything we need. Double check your confidence level. We want 90%, so let's change that to 90%. Hit enter, and we'll see if we got the same thing. And yes, we did. Calculator's a beautiful thing. Alright, let's copy these 2 tests onto our yellow book. So we have, let's write this, hypothesis test. It's number, well, it's stat tests. Number 2, t-test. And then confidence interval is going to be stat tests. What number was it? Number 8, t interval. Okay, there you go. Have a great day.